Good morning, 8th graders. Today we will be starting Unit 2 on electricity and magnetism. I hid lessons 1, 2, 3, and 4 in the OLMS, and we are starting today on lesson 2-5. Please be taking notes when you are doing your lessons asynchronously and adding to them in class. I am not going to be pausing today, but I will give you access to this slideshow later on. That does not mean that this is the only time that you have to take notes, and alternatively, it doesn't mean I'm not going to take notes. I'm getting the PowerPoint later on. Take notes if it is something you do not know by heart, understand, will come up later, and I will be collecting notes. These are our classroom expectations. Please be sure you are engaged and participating, remaining on topic, following directions, and being respectful. You know the deal. Most of you guys, I'm so sorry you have to hear me do it all the time. Most of you are on task, and I love you. Thank you so much. But if you are one of my ghost kiddos, it is a waste of my class time to check up on you. Are you there? Are you there? And as you know, if you're not there, I have to remove you from class, and then I have to follow up with parents. So, everyone who participates, thank you so much for making Miss Birch's, it's not even my job, but making my headache lessened. And other kiddos, just be engaged, okay? Any day is your opportunity to change the way you do something. So, if you've not been engaged, be engaged. What a better time than the beginning of semester 2. All right, 2-5, magnetism. Magnets. Magnetism is a property of attracting certain metals. So we will learn about different elements, metals and nonmetals on the periodic table, and some of them might have the property of magnetism while others may not. Not every metal is able with magnetism. Magnetism is an invisible, non-contact force. So you might be thinking about how if you have two magnets, they will like zap together and snap. Their pull and their attraction to come together was happening before they were touching. So that invisible force was happening with no contact. There was a magnetic field surrounding the magnet that then pulled them together if they were attracting forces, or pushed them apart if you've ever played with magnets that repel and they just can't quite connect. I'll let you guys read for about half a minute. Purpose of magnets and common uses. You can see here fridge magnets, what the magnet would look like at the junkyard, which I find the most interesting. It's kind of, if you ever saw, I think it was like Toy Story 3, when that like strawberry bear and they were all like running and like trying to save each other the toys. There's big magnets at the junkyard to help sort trash and reuse whatever metals we can, but they have to be the specific metals that respond to a magnet. And there's even magnets in certain electronic devices, holding them together. Here are some magnetic materials as well as their abbreviation on the periodic table. So cobalt, iron, nickel, and steel are all magnetic. So on the periodic table, the big C, the big I, the big N, and the big S, those are magnetic metals. Not that this, changes your understanding anyway, but these are what those magnetic metals look like. All of them kind of appear in that silver fashion. The law of electric charge: like charges repel, opposite charges attract. So two negatives, they're going to push apart. Two positives, they're going to push apart. But a positive and a negative, oh boy, are those going to want to come together. I'm still here, just letting you guys have a chance to write that down. Here's a nice graphic that you could also add to your notes. I personally really respond well to an easy to reference graphic versus, paragraphs and paragraphs of information. So if you have a classic like North Soul, well, I almost tried to say North Pole and South Pole at the same time there. North and South Pole magnet, that's what I was kind of saying with positive, negative there. The South and the North are going to attract, whereas if both of the South facing sides, those same poles will repel. Same thing as I was saying with positive, negative. But this graphic, if you put that in your notes, is so easy to reference and remember. Oh, yes, the law of electric charge, which is a little bit of common sense. So that invisible force I was talking about earlier is a magnetic field. It surrounds the magnet and all of the air and material around that magnet. So even when those magnets are not touching and there is no contact yet, there is still that magnetic field surrounding each. And not only are there magnetic fields surrounding a magnet in your hand, but around the Earth, which is why we have a North and South Pole and why compasses work. If you want to get your mind blown, look into how exactly it is that a compass points north. A little bit different here. Electromagnets. So magnets are a naturally occurring substance, phenomenon, whatever you want to call that. Whereas electromagnetics are a magnet, okay? They do point a certain direction, have an attraction, but the magnetic field is not produced naturally there. It's produced by an electric current. So that iron nail, if we go all the way back over here, iron is a magnetic material. We know that. So we have an iron nail that has magnetic properties. But we're going to cover it with a coil of insulated wire and attach it to a battery. Batteries have power, electrical power, and that insulated wire, because it's letting us know that it's insulated, there's conductors and insulators. That is telling us that it's going to help the battery, but it itself is not a magnetic property item. Okay, so this is a very simple electromagnetic conductor closed system there. And similar to the magnets we were showing with the north and south, and I was calling them positive, negative, that's like the different sides of a battery. If you have to put it a certain way into a remote or a certain way into, the beeping monoxide alarms in your house. I hate that beep. An electromagnet, after that long spiel, everyone, my apologies, is where there's a magnetic field produced by the electrical current. Okay, so electricity is needed in order for it to be an electromagnet. I'm going to let you guys peruse over the objectives there. These are the objectives for some of the lessons we skipped in the OLMS, as well as some we are doing this week as we take on Unit 2. But you will want to be able to explain how objects that become electrically charged gain or lose electrons. So we started to touch on that during our chemistry unit about how the outer shell of electrons is either bonded with another. Be nice, Mimi. Sorry about that, everyone. The outer shell of electrons is either shared or transferred, depending on whether it was a covalent or an ionic bond. You'll need to know about electrical fields, electrical currents, conductors and insulators, and we're about to play a game here in just a minute to give us a better understanding of conductors and insulators. All right, moving on. Again, you will get access to this PowerPoint later. Here is some electricity and magnetism vocabulary I would like you to jot down, and I will set a timer for you engagedly for 2 minutes. Conductors, dipolar, domains, electrical current, electric current. Circuit and current, electrical resistance, electromagnet, electroscope, eventful, galvanometer, generator. So go ahead and jot those down, and then if you don't see or hear a definition in your asynchronous time, it'll be important to get those definitions from the OLMS or from the internet and have them in your notes. Dominga Cruz, get down. Quiet, get down. Mingy. There are 4 fundamental forces in the world, and the one that controls nearly everything you touch and see is the electromagnetic force. Electromagnetic force is commonly explained in 2 parts, the electric force and magnetic force. What are these and what do they do? Again, this is a question you will want to have answered in your notes. Take a look here at electrical charges and electrical current, 2 of the words on your magnetism vocab list. Do not write the whole paragraph, okay? Find a concise way to reword it. This is a big lesson to learn about taking notes. Writing down every single thing, not helpful for you. Some of us love writing notes and are handwriting queens. I love using my pretty handwriting, copying it word for word. Not helpful. What you want to do is read it, think about it in your head, and synthesize it into a smaller statement using your words. So let's say electrical current. Let's read that big one and see what I would do to make that easier to put into notes. When lightning strikes, electrons are moving from the clouds to the ground. Different materials are easy for electricity to flow through, like this copper wire. Some are almost impossible to flow through, like this wire's plastic coating. That's conductors and insulators that we're about to play a game with. Some materials, like a light bulb filament, glow when electricity moves through them. So, electrical current. Writing that whole thing, not going to be helpful to you. So you are going to say something like, the flow of electricity through a conductor from one region to another. Example, copper wire, lightning, light bulb filament. Done. One sentence, a little broken. Notes do not need to be perfect. How do charges move? In these examples you just gave me, they're moving through a medium. So conductors and insulators are 2 words that you absolutely should have down in your notes that have been dropping a little bit here and there. Conductors and insulators determine whether a charge moves through an object. So most metals are conductors because those electrons are free to move throughout the metal and move the charge. Insulators, however, do not have the charge moving through them. So that's plastic, rubber, and if you've ever, I feel like you guys are too young to have worked with it, but if you've ever worked, on a car or on a computer or on, I'm trying to think of some other examples, but there's so many things that when you work with the wires, there is a part you can touch or you can't touch. There's usually a plastic piece, a plastic coating, an end little part to grab, when you're under the hood of a car or whatnot. And those are insulators so that, the person working with the electricity, we know whether it's a house, a car, whatnot, an RC car, isn't immediately shocked. So, word of the wise, working on anything, make sure it is turned off before you are working on that, and to be grabbing a portion of which is an insulator, not a conductor. Okay, so let's play a little game. You tell me if it's a conductor or insulator in the chat. Conductor or insulator, this metal key. Okay, past Miss Birch, who's recording this, is going to look into the future right now and say, yes, nice job. I'm so glad so many of you knew that was conductor. In fact, like nearly all of us knew that that was conductor. Give yourselves a pat on the back. I hope I'm right with this future telling. Rock. Is it a conductor or an insulator? I'm going to give us like a countdown on the next one, maybe from 10. Nice job, everyone. This gold bar. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Thank you for those answers, everybody. Another one, conductor or insulator, this brick. Come on, you guys. Think about it. Yes, there we go. What amazing answers, I'm assuming. Let's see, do we have one more? Are we done? One more. Copper wire. What do we think, conductor or insulator? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, thank you. Final answers. Water. I feel like this is my tricky one. Either my last tricky or like we're getting into the tricky ones. Is water a conductor or insulator? And I'm going to give the answer away a little bit right now with my hint. If you've ever been on a swim team in a swimming pool and, you know, during swim practice, like a storm happens and they're like, get out of the pool. Why do you think? That's a very good girl, Mingy. Good girl. That's a good, quiet, good girl. Good, quiet dog. All right, moving on. I took out my AirPods to praise my dog, you guys, so I hope you didn't still hear them. What is electricity? Electricity is movement of charge around a circuit. We call this electric current. So put that in your magnetism and electricity vocabulary. And I'm going to check up right now and see if I should stop here or keep going. I'm on slide 26 tomorrow. Okay, I'm going to do one more and then we will start Tuesday off with videos. Maybe we'll watch. Actually, we're going to watch the videos today and then we will start tomorrow on how does lightning form, I believe. Okay, let's finish up. Hope you got that jotted down. Here's a little bit on electrical currents, magnets, and magnetic fields. Let's take a couple of minutes here to read, synthesize the information, and paraphrase it under your definition portion of your notes. Do not write it word for word. I'm assuming that present-day Miss Birch paused it engagedly and gave you the amount of time you needed. I will be moving on. What is an electrical current? What is a circuit? How does it all work? Let's check it out.